used in major applications like audio and speech processing, telecommunications, image and video processing, underwater communication. In underwater, mainly we use the acoustic signals because in terrestrial domain now we use the radio frequency signals. Those does not work efficiently in underwater. So we use acoustic signals. So because of ship movement and then underwater mammals, those underwater life movement, so we have some noise. So we should remove those noise using the digital signal processing to transfer to get the actual data. And biomedical engineering also many applications like ECG signals, SpO2 signals, respiration signals, various signals require processing. And then another area, as I told, load cell and EMFC signal processing. So when we come to underwater communication majorly used in underwater acoustic sensor networks. When you take VIT-AP, there are various applications like industrial applications, military applications, and scientific applications. These are the broad areas. And when you take industrial applications, there are underwater pipeline monitoring. One of the things like to transfer the oil from different countries, they use these underwater pipelines. So if there are some leakages can happen. So to detect that one, so underwater sensor nodes will be used. And another one is fish farming, like to measure the fish growth and which area they have feeding and all those things to measure. We can use this underwater acoustic sensor networks. And majorly in the military domain for harbor security and surveillance can be used. The scientific domain, the environmental monitoring for tsunami warnings and other things, we can use this Inauguration. So if you see here, so better I will show here. So this terrestrial communication, and this is water surface, and then this is underwater. In underwater, we deploy all the nodes, AUVs or autonomous underwater vehicles, unmanned underwater vehicles, and various nodes in between or on the bottom. We can install and we can cover the area. So these underwater nodes, they use acoustic communication, whereas terrestrial, to transfer this data to the terrestrial networks, we use radio frequency communication. So for the transferring data from underwater to terrestrial, these gateways are helpful. The gateways modems, they use the major protocol translation. So the gateways can be ships or underwater buoys. So these gateways are installed here. In the underwater pipeline monitoring, if you see here, if some leakages will be, if it happen, so those are transmitted to the observers. We are observing these pipelines. And so here the sensors are located. Some sensors are located inside the pipelines. Some sensors are located the outline, so outside the pipelines. Inside the pipeline, they measure the flow, speed and all. So if any difference is there in the flowing of oil, so it will detect that one and it will report to the database. Next is in the fish farms. RFID tags will be used for the fish to identify the each fish, and those are those, and the sensors also will be attached to each fish. So to find the producing area, species, and some of the fishes they need a different water condition. To check the water temperature and other things, they use sensors, and those sensors data will be transferred using UWS and network. So this is one of the application area. And this is regarding harbor security. If any unwanted submarines or intruders comes into the those sensitive areas, so it can be reported using UWSN. So this UWSN has several limitations. Network reliability is one of the issue because links are not stable, and in underwater we cannot achieve data rates, higher data rates. Because if you want to achieve higher data rates, you should use powerful modems. When you use those modems, it is dangerous for the underwater mammals. Underwater life can be affected. So, because of that reason, we cannot use larger transmission power. That is one of the limitations. And the coverage area also, because we are not able to use larger transmissions, we cannot cover major area, so that is one of the issue there. And deployment is very difficult, like the underwater sensor nodes, they work with battery power, so every time replacing battery is very difficult. So to overcome those issues, underwater network management system is introduced. Like, so if you want to check the battery power, you don't need to get the big data. Like it's just network information. For that, we can use like underwater network management system to get like the small kind of information. For this UWSN, I started my career in 2006 with Open University. At that time, we proposed many standards. With ISYC, they have JTC1, Joint Technical Committee. Under Joint Technical Committee, they have subcommittee SC41, which is working on IoT. Internet of Things and related technologies. There we propose UWS and overview on reference architecture, entities and interfaces, interoperability, network management system, overview on requirements and application profiles. So I collaborated with BIS, Bureau of Indian Standards in India, and BIS nominated me as an expert, SC41 to the IoT, Internet of IoT and Related Technologies Committee, SC41, as an expert from the India. So I was the co-editor for all these standards. Again, with I did my postdoc in Oslo University. There we proposed a different standard, which is overview on requirements for base station-based underwater wireless acoustic network, which is they called BUWAN. So here, most of the things are managed by the underwater gateways. Gateways can be on the surface or in the underwater. And it's like you access the cluster head. It will manage all the network information. Whereas all these base stations can be connected to the base station controller. Sometimes directly without base station controller, base station can be deployed in the water surface. So this is a network proposed by the Oxford University. So for this standard also I'm the co-editor. And then from India we proposed the first standard to the C41, UNMS interworking, and the project editor for this one. So we collaborated with NIO. This is National Institute of Oceanography in Goa, and then NIOT, National Institute of Ocean Technology, Chennai. Collaboratively, we proposed this standard. So after that, I moved to different domain, medical domain. I worked at this domain for 2 years. So here I worked for a Korean company called Vistos. Their major product is fetal heart rate monitor. So they have two versions. This is LED version and LCD version. Here these are the transducers. So these transducers will get the signal, and then those signal processing will be done in this device. So they remove the noise and they display the, they display the heart rate here. So this is, if it is, it can be separated by pins. So this is first baby heart rate and this is second baby's heart rate. And they have the one more product, is patient monitor. The patient monitor has different signals like ECG signal and SpO2 signal. This is respiration. So even for process these signals, we do digital signal processing. So if any noise is there, we should remove those noise and we should record the character values here. So currently now I am working with load cell signal processing. So this is the load cell. So this load cell will be connected to the ADC board. So this ADC board will get the analog signal from the load cell. So this weight will be placed here. This 10 gauges will generate current and it will produce the electric signal. So the electric signal will be translated by the ADC board, analog to digital converter to the digital data. So those digital data will process and then will display the current rate here. So these load cells will be used here, loss in weight screw feeder. So here for mixing or closing, the liquids or powders will be placed here. So there will be a screw feeder. It will be processing the powder and it will be sending from here. So whenever the quantity is reduced, so they have to fill it again. For that, this load cell will be used, and those whenever quantity is reduced, so it will be sent to the remote machine. So it will give an alarm, so then they can fill the drug or whatever may be based on the industry. So they use liquids or drugs here. So we experimented with different filters to process this data. This is bandstop filter or notch filter. So this is the actual data which we are getting from the load cell. The load cell data will be filtered in the board. We use the STM32 boards to process this data. If you see here, to get the regular data, it took 0.4 seconds delay. So actually we should reduce this delay to get the accurate results in time. That is one of the challenge. But when we use bandstop filter, we have this delay. So this is FIR filter, finite impulse response filter. So if you see this is the noise data. So by using the filter, we used to get this kind of signal. This is the first Fourier transformation. So using FFT, so signal process. This is just a sample data and then processed signal. But based on the real data, it may be different. So currently, we are working with different missions like these ones. So our target is when we use these missions in the factories, there will be a lot of vibration noise. So we should reduce the vibration noise and get the actual data. So this is one of the collaboration area we are looking like. We'll send you the real data so that if anybody interested, so they can process the data and then which among the mentioned algorithms, there are a lot of algorithms, not only these things, for these are sample algorithms. For different data, different algorithms may be used. Like we are not sure. So based on the real data, if you suggest like this one gives this much accuracy, this much response time it will take to process a signal. So we can have the best one, and we can have the collaboration for the publishing as well as commercial collaboration also we can have, like kind of funded projects. So that's what we are looking at. Another next year we are planning to do the same thing for EMF cells. So this is also safe, but this is very sensitive data. So this also we collaborated with Sadores, German company, to get this EMF weighing cells. So we are working on this one. So after getting data, so how to remove the noise and how to make the result accurate. That's our target. These weighing machines, they work. They will be we deployed in different countries. We are getting complaints like different countries have different humidity and temperature levels. Based on that also, we are not able to get proper results. So using machine learning, like for different environment, what will be the parameters and which algorithm can be applied. So that is one of the research collaboration we are looking for. So you can suggest like we have like feature extraction and for pattern recognition, deep learning models are used, adaptive filtering. So all this can be applied to get good results. For the research purpose, this MATLAB, they are providing signal processing tools. Even Python also has a lot of libraries to process to apply the ML or AI for this digital signal processing. So if you are interested and want to collaborate in any areas, just please contact me. Like not only this current research area, in the previous these areas I had experience. So if anybody want any help, so I could help you in this regard. So for research direction or something. So yeah, that's it. Thank you.
So, any queries from audience? So you can make him for any collaboration, and also you can use the you can use the digital analog signals and also digital signals to make prototypes, and also you can make it as a commercialization. It may be useful for your research based upon your domain. who are working in the signal processing. That means nowadays all of you are using only the collected data set, right? So you can use the real-time data set based upon this kind of signals. So if you have any queries, you can ask our resource person.
If possible, I will send you the real data, which will convert this analog data to digital data. I can send you that digital data that you can use as a data set, and you can apply machine learning filters to the data. That's it. Thank you.
Yeah. Okay. I would like to thank our today's resource person on behalf of VIT-AP management and ICCID RBC committee and our faculty and students and staff members, and also our today's delegates, research scholars. I hope this session give you some the concepts of how can we use the real-time signals for our research based upon the ML and also DL to recognize the patterns. I think you can you can have interaction with him through the mail in future, through your guide also. He will helpful, his speech may be helpful for making the pattern also, because we are all working now only the software designing based upon the DL or ML or anything else security based. But he has given some concept regarding how to make the products, and also we can make the commercialization. So I would like to thank once again, and also I would like to call Professor Shire and Professor Nagaraj sir to give token of appreciation to the today's resource person of this session. Thank you, sir. And also, I would like to convey that the next session will start here itself for the presentation. Thank you.